of the homework discussion question 3. We're looking at the skater observed in the third trial with the following data. I've graphed the data. Here's the pattern. You will need to refer back to this graph as we answer the questions below. We've plotted the position versus time for the skater. And what do I think is happening? What do you think is happening during interval 4 to 6? And during interval 4 to 6, there's no change in position. Therefore, skater is motionless. And how do you know? Because according to the graph, the skater is stopped at 4 meters. So 4 meters in at two different times. That's no change in position. So the how do you know would be actually what I said first. What do you think is happening during the time interval from 6 seconds to 10 seconds? During that time, I would say that the skater is moving toward the reference point, which is x equals 0 meters. The skater doesn't reach the 0 point, but starts moving in that direction. And how do you know? I would claim this to be true because the negative slope implies motion in negative direction. We then want to determine the skater's average velocity from 0 to 16 seconds. If we did this graphically, I came up here and I put in a line to show this. And I would have something that looks like this. So I'd have a line connecting the start point at 0 seconds to the end point at 16 seconds, and the slope of this line is technically the average velocity for that entire trip. So if I could find the slope of that line, then I would know the average velocity for the entire trip from 0 to 16 seconds. We can do that by taking the positions at 0 and 8 seconds and say that the average velocity v is equal to delta x over delta t, and that's going to be xf minus xi over tf minus ti. So if I take it at the 0 and 16 second points here, then I've got 8 meters at 16 seconds minus 0 meters at 0 seconds, and then I've got 16 seconds minus 0 seconds. That's going to be 8 meters over 16 seconds, which is equal to 0.50 meters per second. To determine the skater's average speed from 0 to 16 seconds, we have to look at the equation that's sort of given to you here. Speed equals path length divided by delta t. The path length, we look at the various path lengths here in the motion. We've got a path length here going from 0 to 4 meters, so that's 4 meters. 0 meters here. In this leg, we're going from 4 down to 2 meters, so that's 2 meters. We don't have to consider the negative. 0 there, and then we're going from 2 to 8, so that's going to be 6 meters during this stage. So we can do our path length by saying 4 meters plus 0 meters plus 2 meters plus 6 meters divided by 16 minus 0 seconds, and it equals 12 meters divided by 16 seconds, which is equal to 0.750 meters per second. Note that the velocity and speed for the same motion are different because we had changes in direction. When would speed be a better measure? When total path length matters. As an example, when you're spending time making a trip, it's actually the total path length that determines the total time that you're going to be in your car. So on trips, to determine how much time it's going to take you to do something. Another would be gas mileage. If you went round and round a circular path for 500 miles, your velocity would be 0 because you would have gone 0 displacement, but your gas mileage would not reflect that. Your gas mileage would reflect that you had driven 500 miles and spent gas to do that rather than 0 miles. So speed would be better here. For velocity, when that matters, is if you need to know how far from your start point and also in what direction. Next page, we are to rank the following from, we're ranking the following from the greatest average velocity from the beginning to the end of motion. And I've already ranked those here for you. So we would have C, then D, then F, then A equal to B, and E is the most negative. We didn't have anything for the 5th position unless you moved E there, and you didn't have anything for the 6th position. I considered, as I did this, the displacement divided by time. So considered, since we're talking about velocity, average velocity, I considered the average velocity as displacement over delta t. And it said specifically to make 0 greater than negative and ties are possible. So the first one was C. C is going from 0 to 10 meters in 10 seconds. So this has an average velocity of 1 meter per second. D is next. There we're going from 3 to 10 in 10 seconds. So that's going to be 0.7 meters per second. Then we have, let's see, F is next. F, we've got, so go to a line. F, we would have this as our average. So we would be looking at there going from 0 to 5 in 10 seconds. That would be 0.5 meters per second for an average velocity. Then after F, we have A equal to B. This has no change in position, so no delta X. B equals 0 meters per second. Same here, 0 meters per second. They're just at different positions. Then we had E with a negative slope. We're going from 15 down to 0 in 10 seconds. So that's 1.5 in the negative meters per second. So according to the way we're ranking them, with negative being above or greater than, with 0 being greater than negative, that would place this one last. In reality, if I were ranking these in terms of which one is fastest, then actually this one is moving the fastest at negative 1.5 meters per second, or 1.5 meters per second in the negative direction. But the way you were asked to rank them was putting 0 above negative values. So in the next problem, we want to rank the graphs according to which show the greatest average speed from beginning to end of motion. I've ranked those for you already. F equals E for number 1. So if we come back and look at F and E, F goes from 0 to 10, and then from 10 to 5. So this is 10 meters plus 5 meters would be 15 meters. And E is going from 15 to 0 meters, so that would be 15 meters also. So both of these, the distance equals 15 meters for the path length. Okay. Then, after that, we didn't rank anything for number 2 because 1 and 2 were equal to each other. Then we go to C next. So in C, we've got from 0 to 10 meters, so that would be D equals 10 meters. And after that one, we've got, let's see, D comes next. So we would have from 3 to 10 meters, that's D equals 7 meters. And then we have A and B equal to each other. Both of these, distance equals 0 meters. Distance equals 0 meters. Okay. I hope that explains any questions that you might have come up with as you were doing this assignment. Hopefully you did the assignment, and that concludes the presentation.